Hey there, everyone watching this. This is my first time doing a YouTube video, so this one might be a little rough around the edges in terms of editing, sound quality, and all of that stuff, so please bear with me. I've been wanting to do this for quite some time though, so I'm seizing this new year as an opportunity to get it all started, and let's see where it goes from here. Now the idea is to publish one video per month, roughly, and I will be talking about design technology, Python, coding, software development, and all of the very exciting stuff that we're building around at Orchestra. So definitely keep an eye out for it. There's likely going to be a thing to pick up here or there. So yeah, feel free to comment, feel free to reach out, and I really hope to see a conversation starting from this. So this first video, this first episode, or whatever we'll call it, is going to be about OkPy. Now, what OkPy is a tool to build automation tools. This is my favorite type of tool, the tools that let you build your own tools. And what's really special about it is that it's rather comprehensive in its approach because it lets you build both the back end and the front end for your tools. Before we go any further, and for those who are not familiar at all, just know that you can download Orchestra from the orchestra.online website from the download section. What I will advise you to do is always get the most up-to-date version. So as of right now, at the time we're speaking, 1.6.1 is the most recent version. It's the one with the most bugs corrected, the most features, and it is the most stable one. Just know also that OkPy ships with Orchestra ever since version 1.6.0. And yeah, starting from that version, you will always have it installed when you install Orchestra. When you have OkPy and Orchestra installed and open Revit, you will see these two tabs in your ribbon. Today we're going to be focusing on OkPy. It only contains, by default, the OkPy button that opens the OkPy interface. So this here is the landing page. This is what we're looking at right now, and it looks pretty similar to any modern landing page for any software, with a file section where you can create a new file, open an existing file. There's also a template creation space. We'll get to that later. There's a resources part where we have shortcuts to some of the available resources. There's an OkPy wiki, which is something that we're going to use right now for the purpose of this video. There's a recent files space where you can open any recent project you've been working on. And then there's the helps and settings space where you can set up your preferences and get some information about the current version that you're using. So let's use the OkPy wiki shortcut. That's going to take us right here. And just like a little disclaimer here, this wiki is nowhere near complete. There's a couple of reasons to that. The software is pretty huge and we're just like starting to document each and every aspect of it. So please bear with us. We're trying to get as much valuable information out there as possible. But there's one part that's fully covered, and that's the introduction to OkPy, its interface, and its concept. This is the most important thing to understand to begin with, and this is mostly what I will be going through today. The idea for me today is to sort of convey all the potential of OkPy, sorry, and introduce you to its interface and the way it operates, and also give you a good understanding of what makes it really special. Spoiler alert, it is this inputs part because this is what differentiates it from most of the integrated scripting tools. So let's go back to Revit and click this new tool button. Now this little prompt here is pretty similar to what you get when you start a new Revit project, where it asks you to select a template to begin with. You get to create your own templates, but with Orchestra, we do ship a template for Revit tools. So what I'm going to do here is select this OkPy tool template for Revit and hit the create button to get some code here that's already pre-made and pre-built, and that's here for me to use for the creation of my tool. It contains a header here with some imports of the Revit API, and well, this is all we have here, so this is the most relevant thing to have as a reference for our code. But you are free to build your own templates with anything that you deem useful for your tool creation. What we have here also is a set of variables that contain some super useful things that are, again, pre-built in OkPy. So we get the current Revit documents, the current application, current UI documents, and current UI application. We also have this dictionary here that's called inputs, and we will get to that a little later. What I would like to start focusing on here is this development interface that comes with a debug space as well as a console. And the debug is something that's super useful, especially if you're starting to dabble in Python, because this is something that will highlight every mistake in your code and in your syntax, and we'll list it right here. So here, for example, I have some invalid indentation, I have some missing closing parentheses, I have a missing equal statement here, and anything that's wrong with your code will be highlighted right here. And by double clicking on it here on the list, you will be taken right where you need to be taken in order to fix it, with some indication on what needs to be done for your code to work. So this syntax highlighting thing is pretty useful. Again, whether you're a newbie or an experienced Python developer, this is always nice to have in order to, just write some code and make sure that everything is going to be fine whenever you hit this run button. So this was the number one thing that I wanted to show. Number two thing is the console. Now what the console is the space that's going to display anything that you print. So that's where you get to output some values in order to check that everything is running fine. So let's say, hello, YouTube people, and hit run. So we will get our printed statement right here. And if there's anything wrong with the code, this is also where we will get some information about where it went wrong, with the information about the line and what is expected. We also get the same information here when we hover over this little warning sign. We can clear the console anytime we want and run. You may have also noticed that we have some visual indication on whether the code has run successfully or with errors. Now this gets a little more advanced with inputs, and we'll get to that later. But yeah, right now what we've seen is that we have a debug console that's here showing us live whether our code is sound or not, whether our syntax is correct or not. And we have a console where we get to visualize the output of our code. So for those who've already worked with the Revit Python shell, this part here should feel pretty similar. You should really feel at home here, because this is a piece of code that's going to run in the context of the current Revit document, and that allows you to interact with this document. So this is, I would say, something that's covered by the Revit Python shell. Now, what makes OkPy special is the input section. So this is what sort of ties things together and what fills that gap between visual programming and software development and Visual Studio or any other type of IDE like that. What we have here is a set of inputs. Some of them are out of the box. They are tagged as so with the OOTB tag, and some of them are marked as base. What the out of the box nodes are, or I say nodes because this is the result of years of working in Dynamo. These are not nodes, these are inputs. And out of the box inputs are inputs that we have pre-built and shipped with OkPy for you to interact with your Revit model. So you will have a lot of things that are super useful, like the categories selection, categories input, select model elements input, levels input, all of that stuff. And you get to build your UI based off that. But before we start using those inputs, I would like to spend some more time explaining how these inputs are built. When you type the input keyword here, you get a list of all the base inputs. So those are tagged as base with this navy blue little tag here. And what the base inputs are is a set of sort of dummy inputs that you can start with to create your own inputs. And what you can see here is a little visual indication of the nature of the input. So this is the list of all the natures or the input types that we cover with OkPy as of right now. We have the radio button inputs, the slider input, the button input, text box, drop down, list view, and Boolean inputs. So all of those are covered. And if I select any of these dummy inputs, I will get something that is not super relevant because, for example, here, this list view input is called list view input, and it has A, B, C, D as items that I can pick from. So this is not something that's super relevant. But the thing with OkPy is any input is 100% customizable. And not only is it customizable, but you can also write the full Python snippet that's going to run behind it. For example, here I have A, B, C, D, and this is due to the fact that we have here on the background of this node, this little Python snippet where I have a dictionary that has the A, B, C, D keys associated to the 1, 2, 3, 4 values. And we have assigned that dictionary to the out variable. Now the out variable with 2 underscores before and 2 underscores after it is a built-in variable in OkPy. And this is what's going to get it to understand what we want to display in our input. This information that's stored in the out dictionary is going to be used to display the keys as user-friendly identifiers of whatever we're going to be selecting, and it's going to return the values of whatever the user has selected. So right here we have A, B, C, D. I can go ahead and add a hello world key associated to the value 5, right? We have the same type of debug and console elements that we have here in the editor that are showing me live if my syntax is correct or not. It looks like everything is fine. Now if I hit the apply button, we will see the hello world key appear in the input. And this is how it's done. You can build literally any input you want just based off this logic. Now, all inputs are not going to be using the same logic. For example, here, if I use the button input, so if I use the button input base, This one is going to work in a slightly different way. The code here does not contain much because this is just an event. What we type in here is the code that's going to execute whenever we hit the button that's on the input. If I use the select model element example here, it is built based off this input base, but behind it we have the code that triggers the pick object method from the Revit API, and this is what's going to start a Revit selection whenever we hit the select button. Now what this means is you can build any action really. You can even have a button that triggers some event on your computer, something that's going to open a file or a folder, or that's going to upload a file to BIM 360 or whatever. You really can make it whatever you want it to be. We have some other buttons here. For example, we have the file path selection, we have the folder path selection that are going to be button inputs that let your user select whatever they need for, or whatever you need for your tool to run properly, right? So this is for the inputs. Another thing to know about those inputs is that you get to rearrange them the way you want to through this very user-friendly type of interaction. You can just drag and drop inputs in order to rearrange them and get something out there for users to interact with. What I'm going to do here is hit this file button or file item and hit the save button. And I am going to save this in a folder here. Let's call this my demo tool, right? And now let's close this. And what I want to put the spotlight on here is the fact that these OkPy tools can get shipped with Orchestra, both local and online. By the way, all the local stuff is free, so OkPy is free, local Orchestra is free, and everything that I'm going to show in this video can be done without any type of subscription. So yeah, we have saved our OkPy tool, right? We have Orchestra opened here. By the way, you can open Orchestra, the Orchestra panel, through this little tab here and this button here. And in order to browse your OkPy content, you will need to hit this button here to navigate to the OkPy space. And this is what's going to show you your OkPy tools. Let's hit the refresh button here because I just saved this tool. Oh, maybe it was already there. About this part here, this is the Dynamo space where you get to browse all your Dynamo content, and this is the OkPy space. I had my demo tool here saved under the demo folder, and if I double click it, this is what I get. I get only the user inputs or the user interface parts of my tool. So let's go back to the wiki in order to use just this image here to highlight what just happened here. As a creator, as an editor, we had this interface with the inputs, the IDE with the coding environment, and the debug and console space. And as a user, we only get the input space. That makes it much simpler to use. And all we have to do as a user is select whatever we want, whatever is relevant to what we're trying to do, use all of this interface and hit the run button. So this is how OkPy operates. And editors can create tools with the full editor interface, and when they ship those tools to their users, they ship them in a much easier and much user-friendly way or form for the users to use. Now that we've seen this part here, which is probably the last conceptual thing to grasp about the way OkPy works, I think we can go back to OkPy and build an actual tool to see how this really works. So let's go ahead and build a tool. I'm going to right click this one here and go open in OkPy. We will get back to the editor interface and we will start building an actual tool that does actual things. And the example I want to use for today's video is one that I have also used for the most recent Built Europe event, where I was showcasing OkPy and we built a couple of tools. So this one here is about visualizing warnings in a Revit 3D view. I'm using the Revit Golden Nugget project. So this is a sample that comes with Revit ever since, I think, Revit 2021 or something like that. And it does have a couple of warnings, more than a couple actually. So if we look right here, we can see that it has 205 warnings, right? Natively in Revit, there is no super user-friendly way of visualizing all of those warnings and have them separated from the rest of the elements in specific views. So this is exactly what we'll be building today, a tool that lets you visualize your warnings in a selected view. So here we go. I'm opening OkPy the same way we did earlier. I'm creating a new tool. I'm using my Revit template to create a new Revit automation tool. And starting from this template here, I am going to create some tool using just a couple of lines of Python. First thing to do here is to collect a list of all warnings in the model. All right. Now, in order to do so, I am going to refer to a website that I always use. I know there are other ways to do this, but I really like apidocs.co. So huge shout out to Guy Talarico, who is maintaining this and updating it with every Revit release. So I know that the document class has a warning or get warnings method. This is what I'm going to use here. So in order to get my warnings, I'm going to store them all in a warnings variable. I'm going to use my built-in doc variable containing the current Revit document and use the get warnings method. And in order to make sure that everything is working properly and that I'm getting the right data in my warnings variable, I'm going to print it. So print warnings, hit the run button, see what happens. I can see that I have a list of failure message. Now this is the class in the Revit API for warnings. And I can see that, well, it's all what I was expecting, which is a list of warnings from this current document. Now, what will make it a little more relevant is to let the user specify which category they want to visualize the warnings for. And in order to do so, I need to let them pick a category from the project. So right here, I type category and I get a couple of suggestions. I get the categories input as a drop-down and the categories input as a list view. I also get a cloud version of these inputs, but more on that later, if not in another video in the future. I'm going to focus on these two. The drop-down button for the drop-down input lets me select one category, whereas the list view lets me select multiple categories. So I'm going to place them both just so you can look at them both for a while. This is a list view with all the categories in the model, and this is a drop-down input with all the categories to pick from. I'm going to stay with this one for now. And the only thing I want to show here is that if I enter the customization of this node, you can see that there's a small snippet of code that iterates through all the categories in the current model and returns them in a dictionary with the name of the categories as the key and the category itself as the value. So this is also, I think, a great way for people who are starting with Python to understand how all of this works. Every one of our out-of-the-box inputs is fully customizable and grants you access to the code that runs behind it. So this is, I think, a pretty cool learning resource. Now, there's not much that we want to customize about this code here, but maybe we want to customize the name of the input. So let's say select category to isolate, because this is what we're going to do here. We're going to select a category and isolate the warnings for this category. We can also specify the description for this node. So let's say select the category to isolate warnings for, I don't know if this is very correct, like if this is the correct sentence, but whatever. We can also set up the height, the maximum height of the dropdown if we wanted to like be shorter or bigger. So this is a customization option here that we have for the UI. I'm going to hit apply, and you can see that whatever I've typed here now appears as the label of this input. And if I hover over it, we get the description in the tooltip. Select the category to isolate, this is extra, to isolate warnings for. Now you see this is, well, I mean, there's a couple of ways for you to provide your users with more info about what's going on. Now let's say I select the floors category. So there we go. The user has selected the floors. Now how do we access this selection from this space? Now this is probably the last thing that I haven't shown yet, and that is very fundamental to the way OkPy operates, and it is the built-in inputs dictionary. How do we access these inputs? Through this dictionary. It updates automatically with whatever is happening in this space, right? So right here, what I can do is print, or actually I'm going to store it in a category. So let's say store selected category in a variable, right? Let's call it selected category. And in order to get this value here, I need to use this dictionary, so inputs, and I need to use this key right here, which is customizable, by the way. By default, it will be my input 1, 2, 3, depending on the number of inputs that we have in here. But we can rename it also. Let's call it category to isolate, or really whatever we want. I'm simply going to copy paste it right here. And I'm going to use it as a key to fetch from this dictionary. And just again, in order to make sure that everything is functioning properly, I'm going to print this. And now you can see that we have a, okay, there we go. Now you can see that we have a category here being stored in this variable. If we even want to make sure that it is the one that we would have just selected, I can go ahead and type select the category.name to print its name, so I can see that it's floors. I can select any other category, hit run, and you will see that this always updates to whatever the user has selected. So this is OkPy's magic, really, where it lets you build a UI for your users in no time, because it has a couple of pre-built out-of-the-box inputs for Revit. It also has the base inputs for you to build UIs super fast without having to copy-paste XAML code from anywhere to anywhere, or it's all happening right here in the UI. And you also get to access whatever is happening in this user interface right here in your code through the inputs dictionary. So this is key to the way OkPy works. All right, now that we've seen this, we can start progressing in our code. What we have now is a list of all warnings in the document. We also have a list of selected categories. Actually, not a list of selected categories. We have the selected category, right? And what we can do here is iterate through the warnings. So I'm just going to comment this as we go. Iterating through all warnings and only keeping those from selected category, right? In order to do that, I'm going to create an empty list. So let's call this one my warnings of selected category. This is how you initiate an empty list in Python. Now we need to iterate through the warnings. So for warning in warnings. By the way, you may have noticed that our IDE has some autocomplete features, which is pretty neat. We also have Control F, Control H, find and replace. So a couple of productivity elements that are pretty handy. We're also working right now on implementing ways for this IDE to suggest some autocomplete for the Revit API, and actually any reference that you will add here. So you won't get this with 1.6.1, probably not with 1.7 either, but this is something to expect in a near future. All right, so we said that we were going to iterate through all the warnings, and the warnings in the Revit API are actually failure messages. That's the class. Now, what do we get for failure messages? We get the failing elements. This is how we are going to determine their category. So failing elements equals warning dot failing elements. I don't want to write some one-liners here. I mean, this code could be more compact, but I really want it to be super readable. And I'm going to put it as a resource also on the comments of the YouTube video, because this is something that I'd like to put out there for everyone to use or learn from, or, you know, do whatever you want with this. Okay, so yeah, this is why I'm being very, I'd say, like, specific, and I'm not jumping any step here in the code. So we're storing the failing elements like this. Again, just so we make sure that everything is working well, we're going to print whatever we are extracting from the list of warnings at the end of this for loop. But what I need here is, anytime I fetch the failing elements, I need to actually iterate through the failing elements. So this is another for loop inside this for loop. For failing element and failing elements, I want to check whether the category is the selected one. So if failing element, if we look at it right here, the failing elements method, get failing elements, it returns an element ID, so it's not the element per se. If we want to get the element itself in order to get its category, we need to get the element using its ID. So let's go in and hit doc.get element. I may be going a little fast through these things. This is not really like a Python lesson, but mostly if you are already a little dabbling in Python, something that might show you ways to do things. So I apologize if this is going too fast, but again, all of this will be in the comments, and I'd be super happy to answer any questions about it, either in the comments or in, I mean, I was planning on talking about this later, but we have a forum now. There is a space where you can ask questions. So if you start using OkPy and there's anything that you come through, or like any issue that you encounter and want to discuss or ask questions about, or even if you want to discuss your Python code, feel free to go to the Orchestra forum and say hi. So what I'm doing here is, and I'm going to comment it, iterating through all elements for each warning, right? And for each element, we are getting the element from its ID and checking if its category matches the selected one, right? So if doc get element failing element, this is the getting the element from its ID part, and then we need to get its category, because every element in the Revit API, or almost every element, has a category. This is something we can make sure of right here. There we go. So we're going to get its category. And just in order to make the comparison more secure or robust, I'm going to compare the IDs of the categories. So I'm not going to use the category object itself. I'm going to use its ID and compare it against the selected category element here. So what I did here is I made sure that this is only happening if the category ID of the failing element is equal to the category ID that was selected here through the UI. So if it is the case, then we want to append, and this is how you add an element to a list in Python. We want to append this element. I'm going to add it as an element ID because, well, I already know it, but you, well, might not know it at the time you're building the code. But yeah, I know that I'm going to be using element IDs to isolate things in the future in my code. All right, just making sure that everything went well in my loop here. So I'm going to print this list here in the console. Hit run, something's wrong. Failure message object has no attribute failing elements. Yes, that's because I need get failing elements. Non-type has no object ID. That's line 30. As you can see, I'm using the console to debug my code. So line 30, okay. So there might be some failing elements with no category. That's what I think is happening here. So I'm just going to add a try-catch statement here. And what try-catch statements are is a way to simply disregard the places in the code where it doesn't work. Especially if you're iterating through a lot of elements and some of them may fail, but you don't want your code to simply like stop there and not perform anything. You want it to keep going for the elements that are working. You can use this here, the try except statements. Except is whatever happens whenever this here in the try part of the code doesn't work or returns an error. Let's see if this works. Wow, actually, this category we've selected here does not seem to be very relevant to what we're doing here. So there were no warnings relative to furniture tags, but if we switch this to floors, this should update. And there we go. We have a list of floors with warnings attached to them that is returned in this list now. So this is pretty awesome. Now that we have this, we need to isolate elements with warnings in selected view. For that, the first step will be to let the user pick a view. So again, if I type views here in the search bar, I get a drop down for single selection or a list view for multiple selection. Let's go with the single selection now. And let's pick our current 3D view. I believe this is the one. All right, I've picked this. Now I know that in the view class, we have a temporary isolate method that I just need to refresh my memory on here. So isolate elements temporary. This is great. This is what we want. And what it expects is a collection of element IDs. Now this is also something that I hope will be useful for you to pick up from this video. First of all, let's store our selected view in a variable. So selected view equals, same as earlier, I'm going to use the inputs dictionary, and I'm going to use this key here, which I'm going to rename. I'm going to say that this is the selected view, right? And I'm going to use this key here to fetch the selection from my dictionary. I'm also going to customize the input name. Let's say view to isolate warnings in. Okay, awesome. Now this is much more understandable for our users in the future. So we have selected view, selected a view. We have stored its value in this variable, and now we want to use this method on this view here. But as I was pointing out earlier, if we give it the warnings, my warnings of selected category list here, pretty sure we're gonna get a warning. It expects an I collection of element IDs, and it got a list. Now this is a Python list. This is a .NET collection. So what we need to do here is convert from Python to .NET, and this is something that you will likely be doing quite sometimes, working in Python in the Revit environment. So let's go right ahead and see how we do that. In order to do that, you can import system, and then from system collections generic. This is where the generic collection types or classes in the .NET environment live. And we can import just the list, because I know that this list with capital L implements the I collection interface. We're not going to use the wildcard here because this would import more than we need. So to keep things as smooth as possible, we're just going to bring the list. And in order to convert from a Python list to a .NET list, and this is again something that you should definitely note down if you don't know it already, because this is super useful. Convert from Python list to .NET list. You do it just like this. We can go, okay, let's call it .NET list here in order to really make it super obvious. And this is how you do it. You use the list constructor to create a new .NET list. You need to specify what element type this list is going to be storing, because in Python you can pretty much store anything in lists without declaring it, but .NET has you declaring everything. Now this list is going to contain element IDs, because this is what this method is expecting. It's expecting a list of element IDs. So you put the element type here in between brackets, and here between parentheses, I'm simply going to feed it the Python list. Now this line of code here is converting from a Python list to a .NET list that is of the type element ID. And now if I pass this here, and hit run, it says, okay, generic, no S. Oh yeah, right. Another nice one to pick up here, if you're going to start coding in Python and Revit, or actually in any language, you cannot modify a Revit model outside of a transaction. Now, a transaction is something that you need to start and end, and any modification you want to make to the model through code needs to happen within that transaction. The way you can do it is pretty straightforward. Let's create a transaction here that we call transaction with a lowercase t, because the transaction class in the Revit API actually is built like this with a capital T. We need to tell it which document it's going to run on. Again, we're going to use the default doc variable where we've stored the current document in, and we need to, so after we construct it, so here, constructing a new transaction. Here we're starting the transaction. So transaction.start. We can also give it a little title. This is what we'll see here in the list of events. So we can say OkPy isolate warnings, just so we know what's happening there. Then we do whatever we want. So isolating warnings in view. And finally, we need to commit that transaction. So closing transaction.commit. That's how we close it. And now if I hit run, there we go. All of these floors have warnings. If I select them, I can see it right here. Now this is pretty awesome, right? Okay, let's save this. So save as. Here in this demo folder, let's call it isolate warnings in view. All right. We can even give it a little description here. You'll see where it appears. So this tool lets you isolate warnings of a selected category in a selected view. Let's save this change here. Yeah, save it. We can close it, and here again we need to go in the OkPy environment to see it. Here it is, isolate warnings in view. Double click it, and we get this interface. This is the description that I just typed. So this tool lets you isolate warnings of a selected category in a selected view. Let's hit back button here so we can select a category. Let's say walls, for example. We did floors earlier. And let's select again the active view. Hit run. And there we go. All the walls with warnings are right here. So this is a pretty flexible tool for your users to use in order to help them address all the warnings they have in their models. And with Orchestra, now this is an Orchestra thing, not just an OkPy thing, you can even add them to Ribbon. And here's a little Ribbon button that's going to trigger the exact same tool. All right, I think that's pretty much it for today. It's already a lot. It's much longer than I wanted it to be. Again, I'm sorry if this was a little rough around the edges and still pretty amateurish. I'm hoping to improve on the form and the content as well. So your feedback will be super helpful in doing that. Please let me know if there's anything that you'd like to see covered in future videos, if there's anything that I didn't cover well in this video, and again, feel free to say hi on the forum. I hope to see you there soon. You all have a great day.